Hey guys, welcome to your 9.1 notes on quadratic graphs and their properties. By the end of the day, you will be able to graph quadratic functions of the form y equals ax squared and y equals ax squared plus c. Let's talk about quadratic functions. Quadratic means something squared. That's what a quadratic is. Okay? So it's a function that can be written if the form y equals, and you need to have an x squared. You'll have some number times your x squared plus some number times x plus some number times a c. So what makes it a quadratic is you have x squared. So examples of quadratic functions include y equals 8x squared, or y equals x squared plus 4, or y equals x squared, or y equals 2x squared minus 9x plus 5. You know, there's like literally an infinite number of quadratic functions you can have. This guy right here we call the parent function because he's the most basic one. Everything else like kind of descends from him. So he's the parent function. He's the mother of all quadratic functions, I guess. The graph of a quadratic function takes this shape right here. This U shape kind of deal, that's a graph of a quadratic function. And we call this a parabola. So that's very exciting. It's this U shape kind of deal. We also have this line in the middle. This line that divides it in half, you can kind of reflect from one side to the other. We call him the axis of symmetry. He'll come back later. He'll be an important player later in the game. Okay, the axis of symmetry, fun fact, if you have y equals ax squared plus bx plus c, you can find the axis of symmetry by taking your a and b values, and it will always be the line x equals negative b over 2a. Again, that'll come in handy later. So the point where the parabola crosses the axis of symmetry, this point right here, we call him the vertex. It's where your u like stops going down and starts going up. It's where he changes direction. That's so important way later. The vertex. People often talk about the vertex of a V. We have the vertex of a U right here. So the vertex will always be on the axis of symmetry. It's where the parabola hits its axis of symmetry. And it's either going to be, so here, this is the lowest the parabola ever gets, right? So we call that point the minimum, because that's the lowest it ever gets. Right now, this guy kind of looks like a cup. If we had one that was like going that way kind of deal, if we had a parabola that was upside down, okay, then our vertex, like the point right there, we would call him the maximum. Okay. So if this parabola is, we call this one point, or not pointing down. If it opens down, then the vertex is a maximum. If it's like this, like it's a cup that could like hold water or something, we say that guy opens up. You can remember that because up rhymes with cup and it looks like a cup. And that's the lowest point. Right there. The vertex is always going to be the lowest when it opens up. Okay. So now you find the vertex literally just by looking at the graph, and we'll tell if it's a minimum or a maximum. So the vertex of this graph is right here, which tells us we go over 1, 2, 3, up 1. So the coordinates of this point are over 3, up 1, and this guy is a minimum. I'm going to abbreviate. Over here, our vertex is down here. We go over 1, down 1, 2, 3, 4, 5, 6. So this vertex is at 1, -6, and it's another minimum. Oh look, we have a parabola that opens down. How fun! The vertex right here. To get there, we go backwards 3, down 1. So this vertex is at -3, -1, and it is a maximum because that is the highest y value the parabola will ever have. So finding vertices, plural of vertexes, vertices, is really easy. When you have a picture, you just look for it and you find it. That's really, really nice. That's how to find a vertex. I might ask you also, what is the domain or range of a function? Recall from previous lessons that the domain is the set of all x values that you're allowed to plug into a function. On the other hand, the range is the set of all the y values that will result from the function. Okay. I'm going to graph 3 examples for you, and we'll look at the domain and the range, and then I'll show you a shortcut to graphing, and then we will call it a day. So the most basic way that will always work for all graphs ever for graphing is by making an XY table. So you make an X, you see what Y comes out of it, and you plug those X values into your rule. I put the X value in the middle, and I like to leave a lot of space here so I can show my work. So the rule is X squared. Whatever X squared is, that's equal to Y. Whenever you're graphing, it's important to have some negative values. Start at 0. It's important to have some negative values, so we'll do -1, -2, and -3 and see what happens. We will also continue to go with 1, 2, and 3 and see what happens. Now our rule is, hey look, here are our x values, our inputs, our domain. Let's plug them into x squared. So whatever your x is, we're going to take that value. Those are weird parentheses, sorry. We're going to take that value and we're going to square it. In fact, we're going to do that 7 times. I'm going to take each of these x values and plug them in right there, wherever x is. And then we're going to see what that's equal to. Okay? Okay. I feel like I'm missing something. I guess it will come up later. Okay, so we plugged in. Oh, I remember what I was missing. That was really fast. That's our domain. The domain will basically always be, for this class, will just be all real numbers. Because there's no number you can't plug in here. It gets really complicated later, but for now, your domain is just going to be all real x's. But your y will not be all real numbers. So let's find out. What is -3 squared? -3 times -3 is +9. -2 times -2, +4. -1 times -1, 4. 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. How fun is that? Now look at our y values. What are our y values doing? Well, they start at 9 and they get smaller, smaller, smaller till they get to 0, but then they start to get bigger and bigger again. And they keep growing forever and ever. So our smallest value is here at 0, 0. So we already know that's going to be a minimum. That's going to be our vertex, that's going to be our minimum. Now we take these x, y values and we plug them in and plot those points. So our x's go side to side. Put this right on the axis though. Ah! Spoiler alert. There we go. And then our y's tell us how up and down to go, how far up and down. So if we have -3, 9, we go back 3, which is like here, up 9, which is like there. So our point is here. Next, we have back 2, which is here. That was a really bad line. Meh. Back 2, up 4, so there. So there. -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Now remember, this is not a V. This is going to be a nice U shape. So do your best. I'm not going to judge you, but do your best to hit all the points. So we're going to have a nice curve going through the center of all these points. It'll round out. Oh man, I got to do that again. So we'll go through the center of all these points. It'll round out. So kind of like a flat bottom kind of deal. And then go back. Okay, I don't know what's going wrong with mine. Round bottom and up through these points again. I'm gonna do that. Haha, so nice. Hold on. Hold on. Haha. Okay, cool. What a beautiful parabola I drew. Isn't it great? That's so fun. That's it. That's your parabola. Notice our vertex is at 0, 0. We've got a nice axis of symmetry here right on the y-axis. That won't always be the case, but that's the most basic one. So now let's talk about our domain. Our domain is all real numbers because we can plug in all x's and it will still work. However, what y's are covered? Well, y is only 0 and higher. There are no negatives on our graph. There are no negative y values here on the graph. All of our y's will always be positive or 0. So we say our range y is greater than or equal to 0. Oops. So that's so fun. Okay, cool. XY tables are great because they will work for every single function rule ever in the history of all time, but they take quite a long time. So I'm going to show you a shortcut. I'm going to show you a shortcut even. So here, look, I went through, I made the graph already. Okay, I even plotted the points. But what's the only thing different here? The only thing, you can even see our vertex right there. It's still right there. Because the points started big, they go small, 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 and then they start to get big again. Aww. Okay. The only difference here is this +3. So look at the points. It is the exact same shape we have here. If we took our original guy, don't mind my highlighting awkwardness. If we took our original parabola friend and all we did is we move him up 3, watch this, I'm just gonna, we shift him up, we go 1, 2, 3, it still fits. So all this was a shift up 3. We just moved up 3. Wasn't that so cool? That's it. That's literally the whole thing. So that's your shortcut. You can start with your normal parabola. And a normal parabola, it's that value squared. It's however far right you go, you need to go up that squared. So go over 1 up 1, over 2 up 4, because 2 squared is 4, over 3 up 9, because 3 squared is 9. That's your parent function. And then this adding a number afterwards tells you, hey, just move it up. That's what's up. So there, that's your shortcut of the day. So here you go. If you have a function in the form y equals ax squared plus c, that plus c there represents a shift up. You're going to slide your parabola up. Cool, but now we're going to keep everything the same. We still have that +3, which means up 3. But what is this 2 gonna do? Gonna make it red. What is that 2 gonna do? Well, let's find out. I already took the time to make an XY table for you. Yay. You'll notice that the Y values go down, 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 down until 3, and then they start going up, up, up again. So that tells you 3 is where everything changes. That's the vertex. And I also plotted these points for you. But watch what happens. Even if we shift our function up, oh no. What happened? It got skinnier. It got thinner. Ooh, it slimmed down. So our new parabola is actually way skinnier than our original parabola. Watch this nice curve back up through my points. So good. Okay, nice. Okay. So this A guy up here, because it went from 1 to 2, the bigger A gets, then A makes it changes the width of the graph. In fact, it makes it skinnier. Changes the width. And we'll say as A gets bigger, it gets skinnier. Cool. So fun. So those are shortcuts to help you figure out how are these graphs going to compare. Now the good news is technology exists, so you don't have to redraw your graph every single time. Here, we have a graphing calculator for you. So take some time for the end of your notes. Excuse me, get a really big hiccup, and then follow this link to the graphing calculator. Here I have the function y equals ax squared plus c for you, and I've put them on a slider, which means all you have to do is hold on to this blue dot, and you can slide it to the right, and a will get bigger. Look, it's at like 2, I can make it go 3, I can make it go 4, I can go really slow, but you notice as a gets bigger, the graph gets skinnier. And as a gets smaller, the graph gets wider, 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 wider. Look how wide it goes. It goes bleh. Okay, isn't that so fun? Right? So as A increases, it gets skinnier. And as A decreases, the graph gets wider. But what happens if you have a negative number? It flips upside down. And then again, as it gets bigger, so the more negative it gets skinnier again. Then we have a small number gets wide, 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 until suddenly we have positive numbers, weep, and now we get skinnier again. Okay, so as A gets bigger, that your graph gets skinnier. Now what happens when we change C? We move, as it gets bigger, the graph just shifts up, and then as it gets smaller, it goes down, down, down. But what if it's negative? That just means it's more negative. So that's fun. So we're really just moving the vertex up and down, and that's all. All right. Now watch what happens when I zoom in on a graph. Oh, shoot. Zoom in. It seems to get wide, but I'm not changing anything. It's just that I zoomed way, way in. And as I zoom way, way out, it seems to get skinnier. I'm just zooming out. So that's fun. Okay, back to a normal view of our parabola. Last fun thing, you'll notice this play sign. As I tap the play, it'll move by itself, so you can watch what happens when A changes. That's really fun. You can also put a little pause on that. Watch what happens when you just let C go up and down, and up and down, and then you can make them go at the same time. And then everything is just crazy. So play around with it. Have fun. Yeah, and have a great time in your homework.